Welcome, everyone. I'm Vince Carucci, President of Carmagan Engineering Incorporated, and your moderator for this web event entitled How a Holistic Approach to Mechanical Integrity Delivers Value Beyond OSHA PSM Compliance. Thanks for joining us to learn more about the role of mechanical integrity, or MI, in a plant's drive for OSHA Process Safety Management compliance. To get us all on the same page at the start, in general, holistic refers to something that is all-inclusive. In the context of this web event, it refers to an integrated, multidisciplinary approach to addressing plant mechanical integrity and OSHA compliance. OSHA is in the title of this web event, and you will see that OSHA will be referred to throughout it. But those of you outside the U.S. are not subject to OSHA-specific requirements. However, your jurisdiction likely has similar PSM requirements that must be met. In addition, a holistic approach to MI can address the more active role the Environmental Protection Agency, or EPA, is taking in risk management oversight. No matter, the holistic approach to MI that will be discussed in this web event generally applies regardless of where you are located. So yes, a mechanical integrity program is a functional tool to ensure compliance with federal and regulatory mandates, but it can also be so much more. We all want to be compliant, but what does compliance mean to you? How do you go beyond compliance, and how do you find that added value? As someone who performs global engineering quality control assessments on vendors, contractors, and process plants, one thing I know for certain is that compliance is not just a checkbox. OSHA 1910.119, Process Safety Management of Highly Hazardous Chemicals Standard, covers facilities with a process that involves the processing of a chemical that is operating at or above a pre-established threshold limit, or a process that involves a flammable liquid or gas in quantities of 10,000 pounds or more. A section of that standard, paragraph J, requires that applicable facilities have a mechanical integrity program. The standard applies to a variety of petrochemical and refining plant assets, from pressure vessels, storage tanks, and piping systems to pressure relief, vent, and emergency shutdown systems, all the way down to rotating equipment and controls such as sensors, alarms, and interlocks. As we will learn throughout this web event, by applying a holistic approach to your mechanical integrity obligations, plants can go beyond regulatory compliance and achieve much greater value and benefits. So I now present Refinery Reliability and Maintenance Support Specialist Walt Lambertin and mechanical integrity expert Russ Davis to explain the benefits and value of compliance and how a holistic mechanical integrity program can help you achieve a safe, reliable operating plant. Walt has more than 40 years of experience as a refinery technical support specialist in reliability, maintenance, mechanical, and materials engineering, including 34 years with Exxon Research and Engineering Company. During this time, he has developed and assisted in the implementation of cost-effective general maintenance engineering and turnaround best practices worldwide. He has extensive knowledge in refinery technical organization, mechanical and technical procedures, reliability and maintenance programs, and cost-effective risk-based work practices. Mistras Group's Russ Davis has been designing and implementing mechanical integrity and asset reliability programs for the better part of 25 years, including an extensive background in process safety management, hazard assessment, and consequence evaluation. He has also directed and implemented MI programs for global chemical companies in North and South America, Europe, and the Asia-Pacific region. And now we'll turn it over to Walt for the keynote address. Walt?
Hello everyone. Thanks Vince for that nice introduction. For those of you who don't know Vince, he's been in the mechanical engineering field for more than 40 years. Before he founded Carmagan, He spent 16 years with Exxon Research and Engineering Company as a mechanical engineering solutions specialist working on a variety of plant equipment. So thanks again for the warm welcome and for having me here as we discuss this very important topic. As Vince pointed out, OSHA 1910.119 governs process safety management of plants dealing in highly hazardous chemicals. And those plants are required to have a mechanical integrity program in order to be compliant and to avoid citations and fines. But exactly what actions are required to achieve compliance? Requirements for MI include written procedures and documentation of the program. These written procedures maintain the ongoing integrity of process equipment. Note that they say integrity, which means that they are focused on containment. The program must also feature acceptable employee training on an overview of the process and its hazards. The key here is producing qualified, validated people with appropriate knowledge that can do the job safely and properly. The repair of any process equipment deficiencies discovered during testing must be performed either before further use or in a safe and timely manner. OSHA also requires the presence of quality assurance procedures. New equipment installation or repairs must be fabricated suitable for the process application. This is a large regulatory catch-all. You must ensure that repairs, spare parts, materials of construction, and/or new equipment are suitable for the process and any damage mechanisms that may be encountered. This includes the MAWP, or Maximum Allowable Operating Pressure. Perhaps the most complex requirements deal with inspection procedures, intervals, and documentation. As basic as it sounds, you must perform inspection and testing on every piece of process equipment in the system, all of which must follow recognized and generally accepted good engineering practices, or RAGAGEP. These inspections must have written procedures that define the frequency and testing consistent with RAGAGEP, and subsequently must be documented after occurrence. There are specific requirements around how you document testing and what you do with the documentation once it's been completed. So taking all of this into account, we can now begin to answer the question, what does compliance look like? There are 16 sections of the OSHA Process Safety Management Standard. No other section is responsible for more citations in the latest National Emphasis Program, NEP, findings than mechanical integrity, which accounted for almost a quarter of all citations. The second greatest amount, at nearly 21%, were process safety information citations, those dealing with the documentation of RAGAGEP practices. This means that 44% of all OSHA PSM citations under the chemical NEP resulted from failure to comply with mechanical integrity or RAGAGEP directives. In fact, MI citations alone occurred at a 31% greater frequency than any other directive. Further analysis shows procedures and documentation of RAGAGEP and mechanical integrity methodologies were the two highest cited failures, both of which occurred at 50% greater frequency than sub-areas like process hazard analysis. These statistics indicate the clear challenge mechanical integrity and RAGAGEP compliance present to plant owners and operators, and the subsequent void that a holistic mechanical integrity program can fill in order to avoid OSHA PSM citations, extended oversight, and avoid fines. But it's not just about avoiding citations and fines. There are some who will take the stance that it's cheaper to pay a fine than be compliant. That's not really true. Because when OSHA fines you, they don't just stop there. They can come back and make sure you have corrected deficiencies. And they do have the ability to impose large fines or even close your doors. What's worse than continued fines or a forced shutdown is a loss of containment of highly hazardous chemicals and the potential for events that change lives. That's something that is worth avoiding at all costs. Other consequences include equipment failures, emergency repairs, unplanned plant downtime, and increased operational and/or maintenance costs. So yes, preventing catastrophic events while avoiding added oversight and fines are worthwhile results of a mechanical integrity program. But there's so much more. A holistic approach to mechanical integrity doesn't just say no. Rather, a closed-loop cycle for mechanical integrity opens doors that one focused on sheer compliance does not, including risk management, reliability, and operational victories. A holistic mechanical integrity program says yes. It not only creates a void of fines, citations, and catastrophic events, but it fills in with added value. With that in mind, we'll now turn it over to Russ Davis, who will discuss those benefits and what a sound, holistic approach to mechanical integrity looks like. Russ?
Thanks, Walt, and thanks, Vince. I'd also like to welcome you all to the webcast and thank you for being here. The wrong type of approach can get you simply a passing grade at best and an unsafe, unreliable, and unproductive work environment at worst. That being said, the right approach to mechanical integrity has the potential to change the way your plant does business, the way you make strategic asset reliability decisions, and the way you keep employees and the public safe. In fact, quite a few studies indicate your overall plant uptime increases dramatically when your plant is OSHA 1910.119 compliant. One of the greatest and clear benefits of a holistic approach to mechanical integrity is the documentation and establishment of clear organizational procedures. The streamlining and optimization of information allows for the required documentation of RAGAGEP equipment compliance, as well as ongoing asset integrity, inspection, testing, and maintenance of process equipment. In fact, we look at it from the perspective of there is no program unless it's written down. Without a written program that places a value on consistent, repetitively accurate testing and documentation, all you really have is a checkbox. The absence of these protocols results in inconsistent and ineffective inspections, where the risk of failure is not mitigated, yet early wear out, higher maintenance costs, and the plant downtime are all exacerbated. The presence of an organized, thorough, and accurate documentation protocol increases safety and production time and extends asset life cycles and reliability while lowering maintenance costs. Most sources say the typical ratio of the cost of emergency work orders versus planned maintenance is 4 to 1. Judging from our decades of experience in mechanical integrity and PSM, we can put it between 4 and 1 and 6 and 1. But whatever the number, it's safe to say emergency repairs can be extremely expensive and worth avoiding. Those benefits are achieved because inspection, testing, and maintenance activities are guaranteed to be performed in line with RAGAGEP and in an enhanced interval ensured to detect damage efficiently and prior to failure. RAGAGEP standards and other good engineering practice are developed based on years of knowledge and engineering research, as well as the best practices of a variety of industry and oversight organizations. Highly knowledgeable engineering and MI professionals with years of experience in mechanical integrity program development and implementation contribute to an effective, efficient MI program success. So too do the design, construction, installation, and life cycle inspection and testing procedures that must be developed. Quality procedures contribute to longer asset life cycles and ensure the right inspections and test methodologies are deployed on an asset to keep it safe for continued operation. If you have vessels or equipment operating outside the defined limits, you're just waiting for an accident to occur. Those systems that operate outside their design envelope also wear out quicker, require greater maintenance, and hinder productivity. Every individual responsible for ensuring that equipment is safe and reliable must be fully and adequately trained. The training shall cover the general and specifics of the plant design and operation and the employee's job function as related to that area of the plant. By training each employee in an overview of the process, its hazards, and their applicable safety job tasks, a holistic mechanical integrity program can be achieved. MI personnel must be trained to understand all possible damage mechanisms, the proper test and inspection methods necessary to detect the damage, and the repair techniques that will return the equipment to a safe, reliable state. There's a big why that changes the way people do things. When they understand the why and understand the way they do their job has a direct effect on their own safety and the safety of their community, it greatly raises the level of performance. Comprehensive and systemized training lowers risk of employee injury through awareness and safer equipment operation. Mechanically, training empowers employees toward effective inspection and testing methodologies, as well as the effective maintenance that extends asset life cycles. A holistic MI program produces informed, properly educated, and equipped employees, a benefit that cannot be overstated. At its core, a holistic approach to mechanical integrity marshals all plant resources to optimize inspection and testing procedures, ensuring that they are performed, that their execution and frequency adhere to RAGAGEP, and that they are properly documented. And developing the proper frequency measurement is especially important, be it time or risk-based, since the entire focus of PSM is to lower the risk of operations. For safety purposes, a risk-based approach that is fully compliant with RAGAGEP is the best possible course. It's in the application of a risk-based program as part of a holistic MI concept that plant owners, operators can add value beyond simple compliance. The holistic MI program combats loss of containment, equipment failures, and the increase in risk of operating non-inspected and unmaintained equipment, because what you don't know can hurt you. Not inspecting, not documenting those inspections, and not determining the proper risk-based interval for repeated inspection will very likely lead to loss of containment. Rather, by creating a closed-loop cycle of asset reliability through a holistic mechanical integrity program, plants instead lower operational risk and improve reliability asset life cycles while adopting proactive approaches to maintenance. By utilizing the correct inspection and testing methodologies for the appropriate damage mechanisms associated with each piece of equipment, operational risk is significantly lowered and downtime is reduced, which in turn means increased in productivity and efficiency. Failure to address the deficiencies detected during these inspections can result in catastrophic events, loss of containment, equipment failures, all of which have a high price in terms of budgets, capital, downtime, and resources. We can look back to the recent past and talk about those failures that have occurred just since 2005 that have resulted in huge environmental and human impact. It's always important to remember the primary reason we go to work is so we can come home in the same shape we left. Increased oversight and redundancies inherent in a holistic approach to mechanical integrity ensure the timely correction of equipment deficiencies before return to use and or the extension of use until repair is possible in a safe and timely manner. This means money you don't spend on emergency repairs or a catastrophic event you can spend on any number of other projects. If these deficiencies end up requiring the replacement or installation of new equipment, a closed-loop MI program has quality assurance features that prescribe proper fabrication, installation, and maintenance based on the intended process application. Ensuring equipment is installed according to its proper design and intended service decreases operational risk and increases asset life cycle, all while remaining in alignment with RAGAGEP. So when we talk about a holistic approach to mechanical integrity, what do we mean? It's the mindset that in every action you take, be it required for compliance or as part of the advanced holistic approach for added value, we are driving down the risk of operation while creating a more reliable operating facility. That fact is the foundation on which all added value of a holistic mechanical integrity is built. Early MI programs focus solely on corrosion as the main damage mechanism and utilize time-based inspection intervals for the sole purpose of achieving regulatory, federally mandated compliance. But that old way of thinking holds little value compared to a holistic MI program, which empowers product, service, and personnel resources to aid plant owners and operators in the adoption of a closed-loop, risk-based mechanical integrity program. An integrated one-source model employed by Mistras allows holistic MI programs to produce efficient, proper triaging of a plant's entire needs, identifying and cataloging assets, and history is a necessary first step in the holistic approach. A closed-loop mechanical integrity program also features traditional and advanced NDT services, whose inspection and testing results feed any number of methodologies that add value beyond compliance. Experienced, highly trained engineers also help implement a holistic mechanical integrity program and develop site-specific manuals and program management functions. That level of integration means a holistic mechanical integrity program can even be directed parallel to construction, ensuring compliance prior to startup. Utilizing a site's original construction engineering data, engineers can systemize various plant processes, perform the damage reviews, circuitize associated process piping, and generate isometric drawings with our proprietary IsoTrack program. These can be used for baseline inspections and material thickness exams and used to provide an enhanced foundational picture of a new plant's optimal condition. That versatility and comprehensive programmatic implementation is one of the many areas with added value results from a holistic mechanical integrity platform. A hallmark of added value is the presence of an inspection data management system, or IDMS. Once results are obtained, along with all process safety information for covered equipment, they must be placed into a functional IDMS, like the Mistras Group's Plant Condition Management Software, or PCMS, which optimizes all process safety information, test and inspection data for covered equipment in a usable format for application in the MI program. More widely known as PCMS, the proprietary IDMS offering can be an optimal tool for managing the vast amounts of data a holistic MI program generates. In fact, PCMS was specifically designed to assist facilities in implementing effective, holistic mechanical integrity and process safety management programs. For me, PCMS is a perfect, proactive, user-friendly system. Yeah, of course, I'm a PCMS user and have been for years. The software acts as a companion to the MI program by providing real-time condition representation and directing MI personnel to areas of immediate attention. It's an ideal programmatic system that supports your programmatic approach to mechanical integrity. Some other key benefits of an information data management system like PCMS include storing your asset data and control documents in one place, reducing redundancy and streamlining record keeping, maintaining design and operating characteristics for fixed, electrical, and rotating equipment, capturing activities such as inspection reports, test results, and maintenance requests, interfacing with data loggers, positive material identification equipment, and even PDAs, calculating corrosion rates, remaining life, due dates, and risk ranking, and then planning future activities such as compliance inspections, maintenance activities, and equipment tests. PCMS comes with a full data optimization, conversion, implementation, key performance indicator report development, and turnkey data management support. In addition to PCMS, a holistic approach to mechanical integrity should feature risk-based inspection methodologies and integrated engineering services. As mentioned earlier, we're a firm believer in risk-based inspection and in the idea that everything should be based around risk. Part of the strength of a holistic mechanical integrity program is a risk-based inspection program and calculators that provide targeted procedures for reducing operational risks by identifying effective inspection methodologies based on potential damage mechanisms. Typically, 20% of your equipment causes 80% of the problems. So the first step is finding the 20%. How do you do that? You take a programmatic, holistic approach to your mechanical integrity platform. A facility integrity management program determines the likelihood of both internal and external damage using risk-based analysis of an entire facility or a single piping group. A hallmark of this approach is the determination of all potential damage mechanisms and the subsequent correct inspection and test methodology. From there, engineers review all client data, facility drawings, reports, corrosion records, and other pertinent documents, all to compile the clearest global picture of the plant's condition. These optimize the performance of damage and corrosion assessments, as well as the establishment of inspection and reinspection technique intervals appropriate to identify potential damage, and most importantly, the capability to lower risk. If a damage corrosion assessment shows you will have chloride-induced stress corrosion cracking at some point in your piping vessel system, taking a standard UT thickness reading is obviously not going to be an effective technique. But MISTRAS' holistic approach to MI enables the proper targeting of damage mechanism and subsequently the identification of the correct inspection technique. It's only with this that we're able to then deploy any number of our industry-leading advanced NDT methodologies like phased array, computed or digital radiography, and acoustic emission. As the recognized worldwide leader in acoustic emission, MISTRAS offers industry-unique AE testing capabilities, online and structural health monitoring of tanks, vessels, piping systems, and other critical components, provides plants with a real-time picture of their storage asset condition in the battle against cracks, leaks, and other damage mechanisms. That advanced technology, like the Pocket Core Pack, allows for the detection of active localized corrosion without taking industrial equipment out of service. Even though active corrosion is difficult to detect, AE technology in the Pocket Core Pack is able to listen to the subtle signals localized corrosion emits. AE technology can also be integrated with risk-based inspection to form a global solution for in-service, real-time acoustic emission AE monitoring of your tank condition. With that comes an integrated plan to identify and prioritize high-risk assets along with inspection dates, risk thresholds, and potential life cycle expansion. Without a holistic approach to MI, all these valuable tools never make it out of the shed. But once the proper damage mechanism is identified, a variety of NDT inspections and testing methods for inspection can be utilized. After inspection, a report is then issued documenting which methods were used, the area of interest, any recommended actions, and the NDT inspections needed to verify proper repair. Inspections can be evaluated for effectiveness thanks to our already implemented risk-based inspection program. After that determination is made, you continue to add value by establishing your reinspection frequencies and focus your resources where they're needed most. RBI can not only extend the frequency of inspection on equipment that do not need frequent inspection, but also focus your resources on assets that need increased inspection frequency. Therefore, you are effectively targeting your resources on the 20% and continually driving down your operational risk to the other 80%. Looking at some of the NDT methodologies we use for these inspections, MISTRAS offers a large and varied toolbox, and we can take a look at some. Manual ultrasonic thickness reading. That's a quantitative inspection that effectively identifies and verifies thickness readings and does not require advanced safety measures. There are disadvantages too. If I'm looking for localized corrosion, which is often the case, I would be better off using advanced or automated ultrasonic applications or even radiography. Automated ultrasonics offer more detailed coverage than thickness readings and are a valuable tool in most any fitness for service analysis. In radiography, MISTRAS has the capability to provide not only good standard radiography, which is still very useful, but we can also deploy advanced radiographic techniques that are newer and faster, all with specific features and benefits designed to match an individual plant's need. Also noteworthy is that none of these require insulation removal. Direct radiography features short exposure times and a smaller exclusion zone with instant image processing and review in the field. Similar to DR, computed radiography offers the ability for companion software to enhance, manipulate, and digitally archive shots into easily transferable electronic media once the exposure has been scanned into a computer via phosphorus imaging plates. As long as corrosion under insulation continues to be a problem for plants, real-time radiography will always be an effective tool to combat it. Real-time radiography produces immediate results for weld identification with little to no radiation hazards. It's ideal for piping runs where close proximity and pipe geometry are not issues. Guided wave ultrasonics, or GUL, is the most cost-effective testing solution for long piping segments. It covers anywhere from 1,500 to 3,500 feet per day and delivers a rapid inspection of a long piping segments with corrosion location and semi-qualitative analysis of wall loss. It provides 100% volumetric coverage with limited insulation removals. Then you can follow up with a quantified method while minimizing insulation removal to only those specific areas of concern found with the GUL. Many of you out there have spheres with fireproof legs. I think we've all probably heard of spheres that totally collapsing as a result of corrosion under that fireproofing. But by using pulsed eddy current, or PEC, you can evaluate the steel under the fireproofing and identify any corrosion without removing that fireproofing. These advanced NDT technologies become even more effective in the hands of highly trained and certified technicians that administer holistic mechanical integrity programs. This ensures that inspection and testing is always performed by qualified, certified personnel. Those individuals that are trained properly are much more likely to perform the proper inspection and identify the necessary problems when presented. So whether it's developing, implementing, and maintaining a program from the ground up, or evaluating and optimizing an existing one, Mistras Group utilizes more than 40 years of experience in asset reliability services to administer holistic mechanical integrity programs and other asset integrity management services. So by choosing to close that loop and integrate all MI services into one self-optimizing cycle, plant owners and operators neutralize uncertainty while adding value to already mandated compliance. The result is a holistic, closed-loop mechanical integrity program that continually drives down operational risk and creates a more reliable operating facility by identifying the proper damage mechanisms per asset tested and assigning the appropriate inspection, maintenance, and/or replacement methodology. In that scenario, there is no limit to the value of sound mechanical integrity program. Now we're going to hand things back to Vince, who will present a quick experience study that highlights the success of a Mistras holistic mechanical integrity implementation. Then we're going to take your questions. Vince?
Thanks, Russ. I now want to quickly run through an example that illustrates the realized value of a holistic mechanical integrity program administered by Mistras. Some years ago, a major European-based methanol and ammonia plant operator purchased an out-of-service plant located in Texas. They came to the Mistras Ames Mechanical Integrity Group to use its integrated worldwide capabilities to assist in a project that was both very large and time-sensitive. The purchased plant had to be inspected, the equipment condition needed to be evaluated, and its mechanical integrity needed to be proved before startup, as per the OSHA PSM compliance guidelines. Mistras began with a gap analysis that was followed by the methodical development of mechanical integrity program and procedures. These included visual inspections, ultrasonic and advanced non-destructive inspections, MI engineering evaluation services, and MI maintenance. This rapid, integrated, and synchronized approach provided the operator with the means to bring the old plant into service and sustain continuous operation in a safe and reliable manner. The operator actually had a surprise visit from OSHA inspectors just before the startup. The OSHA inspectors were fully satisfied with the Mistras implanted MI program, and the plant operator was able to begin safe operations on schedule and within budget. It was the holistic programs that Mistras offered above other MI-only providers that saved the operator a considerable amount of time and money. An added benefit was that the real-time condition picture that plant operators had from the MI program implementation before startup. And with that, we will now open the presentation to questions that were submitted by attendees during registration. Our first question: are there any quality assurance procedures in addition to evaluating only maximum allowable working pressure MAWP, that can be useful during repairs, upgrades, or new equipment installation. A lot of people look at MAWP as a normal design standard a plant must meet. A certain pressure or certain pressure, as something you pretty much determine from design books. You choose them, document them, and that's it. But here's a whole other smaller window of operation, which I call the safe operating window. That involves the type of feed you're processing or the type of operating conditions that might trigger a degradation mechanism. For example, take the top of a fractionation tower. If the temperature is near or above the dew point, there's no problem in the overhead lines. But if you're below the dew point, you can have all sorts of acid corrosion or pitting problems. So there needs to be a link to the safe operating window to trigger potential inspection opportunities if you get outside the window, like if you change your crude type, lower a tower top temperature, or something similar. All those operating windows are critical to triggering the potential for more intensive in-service or out-of-service NDT. People look at operating pressure as a one-time parameter and do not link it to an MI program. But by creating links in your mechanical integrity program, you can say to operations personnel, if you violate these parameters, you need to go get the inspection and possibly engineering personnel involved. Now we'll turn it over to Russ for some questions that are in his area of expertise. Russ?
Yeah, thanks, Vince. Let's see, here's our next question. Are documented meetings of engineering and maintenance personnel regarding a change enough to show compliance? If not, what more can be done to add value? Well, what validates compliance to change is the engineering analysis. Engineering calculations done per code such as API 570, API 510, or your design standards, ASME 8, ASME B313, referring back to the construction documents would be your governing standards there. But the bottom line is you need the analysis to validate the fact that any change meets code, and that comes from your engineering calculations. Oh, this next one here looks like it's mine too. Why would I use advanced RT when I can just shoot traditional RT? Computed and digital radiography, along with your digital film archiving, provide a great benefit beyond those of simple radiography or traditional radiography. Mainly the ability to digitally enhance images to create high quality, optimized shots, and the ability to digitally archive data for later comparisons and distribution. The other factor is efficiency, because MISTRAS computed radiography allows for multiple simultaneous plate processing that equates to the production improvement of about 15 to 30 minutes per hour using CR versus your traditional radiography. This promotes same shift response to acceptance results, defects, and rework requirements. And because advanced radiography techniques utilize lower strength radioactive sources, boundaries and exclusion zones are reduced, which leads to a safer work environment for everybody involved. This next one, thanks, yeah. Are piping changes made to NFPA standards OSHA PSM compliant, and do they offer any added value? The standards, the RAGAGEP that applies to your process piping is going to be ASME B313. NFPA standards will obviously apply to your fire system piping for your sprinklers and deluge systems, but that all depends on your piping type. Fire protection under NFPA does adhere to that RAGAGEP, so that would be acceptable. Other types of piping, such as your process piping containing highly hazardous materials, does not fall under NFPA guidelines. Changes made to process piping containing highly hazardous chemicals should comply with your RAGAGEP and your design code, such as API 570 or B313 or 311. But since NFPA standards are not applicable to process piping, they are therefore not applicable to the OSHA PSM standard, not for process piping. So you won't be getting any of the added value that comes with OSHA PSM compliance. Next question. How do I know if I'm using the proper NDE, non-destructive testing evaluation methods? You know by evaluating the damage mechanisms and identifying the proper NDE methodology. Whether it's guided wave ultrasonics or time of flight ultrasonics or radiography. All of these can be analyzed by somebody who understands the damage mechanism and who understands NDE and all the appropriate methodologies out there completely, and someone who can also integrate them into your toolbox. Thanks, everyone. Vince is going to handle the next questions.
Thanks, Russ. Here's our final question. What if I know I don't have a lot of existing documentation? We purchased a lot of plants in the past, and we are unable to produce that data. A gap analysis can identify equipment and the data that needs to be there so you have the necessary information to manage your plant. The necessary data required by OSHA and EPA to manage a program can also be recreated to prove the equipment is fit for service and to prove the equipment is suitable for the process in which it is operating. So that concludes the question and answer portion of the webcast. Thank you for your questions. We now know that the benefits of a holistic approach to mechanical integrity go well beyond simple compliance. Not to be discounted, OSHA Process Safety Management compliance avoids fines, citations, and increased oversight while making plants safer. But the benefits of a holistic mechanical integrity approach add value by lowering operational risk while increasing asset reliability on a plant-wide scale. This can lead to increased safety, the avoidance of catastrophic events, optimized inspection and maintenance procedures, extended asset life cycles, lower maintenance costs, and increased plant productivity. The first step on that road to a holistic approach to mechanical integrity is a gap analysis, featuring a comprehensive plant review. This will identify deficiencies in an existing MI program, then identify and recommend the appropriate corrective measures. This helps clients understand what they have and don't have in place, which goes a long way in determining whether your plant is compliant, reliable, efficient, and safe. For more details on holistic approach to mechanical integrity, visit the website mechanicalintegritycompliance.com. I'd like to thank Walt Lambertin and Russ Davis for their contributions to this web event, and thanks to all of you for attending. On behalf of Mr. Russ Group and Carmagan Engineering, I'm Vince Carucci. Good day.